So, erstmal guten Tag, meine Damen und Herren. Ich freue mich, Sie zum Rollout begrüßen zu dürfen. Ich bin sehr dankbar, dass Sie sich die Zeit genommen haben, heute bei uns zu sein. Heute präsentieren wir, worauf wir monatelang hingearbeitet haben. Da unser Team sehr international aufgestellt ist, haben wir die Entscheidung getroffen, diese Veranstaltung und Präsentation auf Englisch zu halten. So, good evening, ladies and gentlemen. It is my greatest pleasure to give you a warm welcome to our highest and awaited rollout of our newest vehicle, muc023. Today, we will witness the true power of hard work and incredible power of motivation and a shared goal. Your support here today means really a lot for us. So, without further ado, I would like to hand over the stage to our first speaker, Professor Dr. Thomas Hoffmann, President of the Technical University of Munich.
Yeah, ladies and gentlemen, it's great having you here.
Nee, nicht gescheit.
Now it's better. Oh yeah, that's better. So welcome all of you to this wonderful event. In particular, I would like to welcome all our students. You know, look into this round and you can, I think, detect them by your t-shirts. About 100 really highly passionate students, and you are the one to make the TUfast team. I would like to welcome in particular also our Minister of Science from Bavaria, Markus Blume, because that you are here demonstrates once again where your heart is beating for. It's beating for innovation and for technology, and it's beating for the young people, for the next generation to drive innovation for tomorrow. And thank you for being here. I would like to welcome also the second mayor of the city of Munich, Mrs. Hartenschaden. Great having you here. I would like to welcome all the industry partners who sit somewhere here in this room, and there are many of them. Almost 30 partners are the ones to sponsor your work, because without this support, you wouldn't probably not be here, and in particular, this car would not be here today. If we look back to the history of TUfast, it's 20 years back, 2002 actually. 5 students were the first to build the first TUfast car. It was the engine was built then in 2004 actually, and since then you are driven by the passion for challenge, right? That's why you're here. You want to put everything what you learned in the lecture hall into practice. So you would like to build the bridge between theory, knowledge, and hands-on experience. And this is, I think, what these student teams are all about. And if you ask yourself, why are our student teams at TUM so successful? It's because you have the right mindset. You have the passion to go beyond your comfort zone. You go out of the lecture hall and you dare to connect to other students from other disciplines. Only here in this group, for example, we have students from mathematics, from mechanical engineering. I've seen electrical engineering, computer science, but also management. Because managing those guys is not so easy, I can imagine. Managing 100 young people needs managerial skills and organizational skills to build it up like a startup, actually, like a small company, so that everybody knows exactly what she or he needs to do to realize such a car. But it's also the support of your faculty members, that they give you the possibility and support you with knowledge, with networks, because the networks, again, are important to find the right company partners who then help you with equipment, with other type of deliveries that are essential to build such a car. I would like to thank all those who mentored you, because mentoring means that probably also from alumni of TUfast, that they give back to you their experience and their knowledge, so that this is really a huge, or this event just became true because you have gathered like a family of experts with different expertises, as mentioned. And if I looked it up right. Altogether, almost 80 nations are involved in the entire TUfast team, not just in the ECO team. And now, in one of those lines, the ECO team is the one to focus primarily on more sustainable urban mobility or more greener mobility. And if you look at least at the car from last year, you can see that it's designed for optimized aerodynamics and for lightweight, actually. And I'm quite sure what will be here under this curtain. And I think we all are quite excited to see in a minute or so, or in some minutes, what you prepared to win the next competition. The ECO competition, and I heard it's in about 4 weeks, so just 4 weeks to go. And you may know that here at TUM, we really love such challenges. These educational challenges is something I think which also stands for TUM, but we even more love if you win. And that's, you can be sure that we as TUM and me as president, I will cross fingers until you will cross the finish line. So welcome, thank you so much for being here, and you can be sure also in the future that the university will support you as much as we can to make such events become huge successes. Welcome, thank you.
Thank you, Mr. Hoffmann, for such an inspiring speech. Now, I'm more than thrilled to welcome to the stage our next speaker, our State Minister for Science and Arts, Markus Blume. Thank you.
Yeah, thank you so much, dear friends, dear President Hoffmann, dear Mayor, and dear TUM family. It's really an honor for me of being being a part of this initiative and this idea and this spirit of this team of TUfast. At first, I thought TUfast means something like fast and furious, and I'm sure you are also fast and furious, but later on I understood it's not only about being fast and furious, but also being ecological. And for that point of view, I think you really are in a position to properly address the major challenges and the big transformations going on in the world. There are at least two. The first is the technological revolution going on day by day. And the other one is fighting climate change and coming up with new ideas and new solutions of future urban mobility, for example. And for this reason, I really love what I've seen in the past, and I'm very excited and curious to understand what will be the car of the year 23. From my perspective, I must be honest, I love my bicycle, but a little bit more like fast cars. Maybe with the mayor it's a little bit different. She's very much on bicycle, and I'm not sure about her position to cars, but I'm sure we all are with you when you're in the process of preparing for the next challenges and for the next competitions. And to let me be very clear, we are all very proud of the TUM family, of the Technical University of Munich, and of this fantastic student teams. When I come to the TUM family, dear President, it's really a different spirit compared to other universities and compared to former times. You have teams in basically every field. A couple of weeks ago, I realized there's a rocket team, and they are about to bring a rocket to the sky in Texas in a couple of months. We all know about the Hyperloop team. I'm a big fan of the Hyperloop team. They won basically every competition of Elon Musk. And I'm also a fan of the TUM Boring team. So they are in basically winning the boring competition of Elon Musk. And maybe, dear Mayor Habenschaden, maybe this could also part of the solution, how we can move on a little bit more quickly when it comes to zweite Stammstrecke here in Munich. So we have the guys here. You are the guys that understand how to move forward quickly. how to come up with new solutions, and how to combine technical progress, how to combine innovation with the responsibility for being sustainable. And for this reason, I'm really proud of being here. And we are all proud of your activities in the past, and we are very much looking forward when it comes to the next competitions. So all the best and very much of tailwind for these challenges. The Free State of Bavaria, we are with you, and we keep all our fingers crossed. All the best.
Thank you, Mr. Blume, for such inspiring words and insightful words. Now, I would like to welcome our last speaker tonight, the second mayor of Munich, Katrin Habenschaden.
Thank you very much. And can you hear me? Yes. Thank you for making it a little bit more comfortable for me in the end of a long day. That's very kind. Dear Mr. Minister Blume, dear Markus, dear Thomas Hoffmann, to avoid to say, dear Mr. President, dear students. It's good to see all of you here. And to me, today's topic is energy efficiency. When I prepared for this speech, I did a little research on what is possible with 1 kilowatt hour. This is what I found out. I could drive a combustion engine car for approximately 2 kilometers. On an electric car for 5 to 10 kilometers. And well, that would not even get me back to our city hall or back home to Munich-Aubing. With 1 kilowatt hour, those who have the endurance can ride a bike in the flat for 200 kilometers. That's already a lot better, but that would take quite a while. Maybe 1 day, maybe 2 days, maybe 3 days. That's me. And with 1 kilowatt hour, you, ladies and gentlemen, could also ride your TUfast ECO prototype of 2022 for 270, is that right? Kilometers? Yes, I see you. And I'm really asking myself how this is even possible. And now you want to take it even further with your new prototype, and that's muc023. And this is, to me, just incredible. It's so incredible because, first of all, your project tackles one of our major problems: resource use and efficiency. We don't have the space, Munich, for example, to get bigger and bigger cars that are flooding our streets, leaving no free spaces behind. Plus, really, who needs a car that weighs more than 2 tons? A car that needs approximately 10 square meters just to park 23 hours per day? And I would say almost no one. And we don't have the resources to fuel all of them without harming the climate. The minister mentioned that. Not even the electric ones. At least not until we are able to increase their efficiency drastically. Hence, your target to build a small, efficient urban vehicle is a great fit to Munich's mobility strategy 2035. And these are the cars I'm very much in, Mr. Minister. One of our goals is to use space efficiency. And the limited use of space in Munich of your vehicle contributes perfectly to exactly this goal. Additionally, by reaching the next level of energetic efficiency, such a vehicle can act as one of the cornerstones to reach our goal of climate neutrality in 2035 in Munich, which is ambitious, and I do know that. So please, take your ideas and your approach to the car manufacturers in the world and in Munich and show them how a car that is compatible with a dense, lively city needs to look like. You know that. Your project is also incredible because, secondly, it is a perfect example of where innovation should lead us. It's not about bigger, faster, or just more. It's not aimed at maximizing revenue. No. Your project, this project, is about reaching as much as possible with as with as little resources as possible. And that's the way. And it has the societal and environmental impacts of innovation in its focus. And that is the approach which is really needed on the whole world and in Munich as well. And thirdly, your project shows how it is possible to push further when we all work better together. You can be proud of a student team of more than 80 different nationalities. And that is why I'm proud too, and that is why I try to hold this speech in English for you. And you all have different personal and professional backgrounds, and you combine all that knowledge, the experience, and this is how you reach the next level of efficiency. To me, this is a prime example of why people need to work together to change the world for a better. Thus, your approach targets one of our main problems. It has a strong focus on the environmental well-being, and it shows the beauty of teamwork, and that is what I can see here, which is just incredible. I'm especially proud that here in Munich, there are so many young talents who really want to shape the future and create a better tomorrow. And that in Munich, we can offer an excellent education at a university like the TUM. Its networks, resources enabled you to achieve what you did. So I already wish you all the best for the upcoming competition. Fingers are crossed. The Shell Eco Marathon 2023. And yes, I do cross my fingers for you to come back with the first place. But now I guess everyone is curious to see the next prototype, me too. So I quit talking in a language I'm not that very much good in, and I'm really looking forward to the presentation. Thank you all for your pretty good work.
Was macht der da?
Now, I would like to turn over the stage to our team so you can have a brief idea of what our story is and also to explain why we are all here today. I'm pleased and give a warm welcome to our technical director, Zeynep Aydin, and our team manager, Lev Dalin.
Good evening, ladies and gentlemen.
Also a good evening from my side.
Today, I want actually to create for you an evening of imagination. Have you ever wondered, how will our future look like? How will we sustain ourselves? And what innovations will help us thrive? While much of what lies ahead remains in the unknown, we are here today to answer one topic. How can we make our means of individual mobility more efficient? And building on that, how will this efficiency pave the way to our future? In a world where the scarcity of energy is one of the great problems for our time, it's of utmost importance that we find ways to optimize our power consumption per capita.
And this is what this evening is all about. Today we will introduce you to our latest innovation, muc023, a hyper-efficient concept car designed and built by students to revolutionize the way we think about transportation. And it's not just a car, it's a testament for our unwavering commitment to innovation, sustainability, and the pursuit of efficiency. We strive to build the most efficient car in the world. But how do we do this? There are numerous factors that contribute to a car's efficiency, and we've carefully considered them all.
Of course, aerodynamics.
Yes, aerodynamic drag is the force exerted on a vehicle as it moves through the air. It is caused by the resistance of the air to the vehicle's motion.
Also, weight plays an important role.
Exactly. The greater the weight, the more power is required to accelerate the car to the desired speed.
Lastly, there are many other critical losses in the system.
Be it mechanical friction or electrical losses, they all play a major role in the efficiency of our car. And we worked on optimizing all of these variables. As we embarked on the task of designing our latest vehicle, we knew that the expectations were sky high. After all, our previous car, muc022, which you can find over there, set a remarkable benchmark with its featherlight competition weight of just 76 kilograms and an impressive drag coefficient of around 0.16. Inspecting each system meticulously, we went out of our way to improve every aspect of the car. And we succeeded. Looking at the car now, we can proudly say that we're close to the limit of technological feasibility. And I can assure you that the car you're going to see tonight is way beyond anything you can find on the streets.
We started from scratch. No team, no budget, no design. All we had was the experience of participating in the past season. And everything that pushed us forward was the thirst for innovation and the hunger to outmatch the previous car. But that was all we needed to give us a strong start. We recruited team members and distributed the responsibilities. The following months were used to design and develop our car to become the futuristic urban vehicle standing here today. Already during the design phase, we kicked off our production, starting the creation process of our car. From then on, every day from morning till night, you can find 2 to 6 of our team members in the workshops, advancing the progress of manufacturing. Week by week, day by day, everyone found time to join the shifts, next to all obligations in private life and university. After relentless efforts and great teamwork, we managed to finish this car in only 7 months of production, an outstanding accomplishment. It was almost never easy, but that's what made it great. If everything went smoothly, the experience would never be as lasting. It's the moments of struggle that you remember, the stress of an issue coming up, putting the entire project at risk. But of course, just as well, the relief after solving these problems leaves a mark on your memory. What cannot go unmentioned here is the privileged position we are in. Sitting at the Technical University of Munich, we have access to facilities and infrastructure many of our competitors can only dream of. We have the best talents right outside our lecture halls. Additionally, the close cooperation with TU Munich gives us the opportunity to create lasting academic works in the form of bachelor and master theses, project works, and seminar studies. Only with this synergy are we able to go to the limit of technology and excel with our work.
But of course, we don't want to promise you the world without delivering something tangible. This is why we will prove the concept or the validity of our concept on the track. In only a few weeks, we're going to travel to the Paul-Armagnac circuit in Nogaro, France, where we're going to compete against university teams from all over the world in the efficiency of our car. Carrying a legacy of successful participations in the past, we will go there once again to achieve the best results. Our team has worked tirelessly to improve every aspect of the car, and we're confident that it can outperform anything on the track.
But how can we be so sure of that? After all, we're not a company with immense financial resources. We're not a funded research project. We are a group of students that come together to create something greater than themselves. With over 80 members from 34 different nationalities and a vast variety of faculties coming together, this project has all it needs to succeed. The diversity of our team members is one of our greatest assets. This diversity provides for a unique dynamic where everyone feels welcome and doesn't fear radical ideas, and pays off being a part of it. The experiences you take home and the lessons learned for your life is something you'll never forget. The members form the project, and the project forms them. We not only become better engineers, better managers, better team workers. It is a lasting impression on the way we do our work. We all learn that there are no problems that can't be solved, that creativity has no limits, and that it takes courage to innovate. We start our careers with a different mindset than many others. For us, it's not only about quickest acceleration, highest speed, or biggest comfort. We strive for efficiency, sleek design, and achieving the same performance with a fraction of the energy cost. And in this way, we will go out to leave our mark in the world, building way beyond the boundaries of our season. But before looking too far ahead, we still have unfinished business. The upcoming competition is the defining point of our season, as we know that we are ultimately measured by our results. We will go to France as a team, because we built this car as a team. And we are here today as a team. It's not possible to finish a vehicle like that with just a couple of members. This car comes together with many contributions of our diverse group of dedicated members.
Like any successful company, we need marketing, money, and event management. We need a team that can handle logistics, procurement, and material sponsorship. And luckily, our management and PR sub-teams are experts in these areas, paving the way for the success of the entire project. Of course, we also need a chassis that's lightweight, but still capable of withstanding all the forces that will be encountered. And this is the task our vehicle body engineers take pride in. But a chassis alone is not enough. To make sure our car can move, we also need a running gear that connects the vehicle to the street and transfers the energy from the engine to the wheels. And finally, to bring our car to life, we need an electrical team that works tirelessly to integrate the electrical powertrain into the car. But that's not all. To make our car fit for future mobility, we need an autonomous team to develop advanced self-driving software for urban concept maneuvering. And to provide you with a comprehensive understanding of the entire project's development, our 6 sub-teams will showcase their journey today. Without further ado, let me reintroduce you Adrian Fernandez de Dios, our Head of Management and PR.
Good evening once again. The management and PR team here at TUfast ECO team plays an important role on providing the necessary resources and help this team to create and innovate without limit. Thanks to our expertise in 3 key areas: marketing, event management, and monetary sponsoring. Sorry. Sorry guys. Thanks to our expertise in 3 key areas: marketing, event management, and monetary sponsoring, we can make this all possible. Our 6 marketing members take on the responsibility of engaging and connecting with our fellow students, supporters, and individuals who share our vision. They oversee everything from crafting posts, stories, captions, to the branding of our vehicles and bringing awareness of what we strive for. As an example of our commitment to excellence, I will now share with you our recent success on Instagram. Over the last 3 months, we have reached over 6,400 accounts, an impressive number. However, here at TUfast ECO team, we always try for success, and our social media team rose to the challenge. By implementing a new strategy, they managed to increase our reach accounts by 300%. Additionally, our reels have gathered over 120,000 views today, reaffirming that we are actually on the right path. These achievements serve as proof of our team's hard work and dedication of creating engaging content for our audience. As we recognize also the very important significance of building connections with industry experts and other professionals, we are prioritizing our efforts on LinkedIn, and we are striving to enhance our interaction on the platform. For us, it's very important to bring awareness to the fact that everyone can be part of something revolutionary, such as the TUfast ECO team. In the end, we're just a bunch of students working together with a common goal, trying to redefine what we understand under efficiency. And that is exactly what we want to show on all of our platforms. We are gathered here tonight to commemorate a big milestone. And it fills me with great joy to see so many familiar faces across this room. TUfast ECO team is just not a team, it's a family. It's a family of over 80 active members. And event management played certainly a part in this by their efforts on recruitment and simplifying the direct interaction with the students to the tireless work on bringing this beautiful night together. Now, I would like to revisit a point I made earlier. Create and innovate without limits. This is what every engineer dreams about. From the start of the season, part of the management team had the goal to make this possible. Thanks to our hard work and the generous support of our 22 monetary sponsors, we made this dream a reality. During this season, we managed to increase over 80% more financial support. This gave us that extra mile to create, evolve, and thrive. Your support and your contributions were key to our success. They allowed us to get access to the best technology, pursue our journey without limitations, bringing efficiency on everything of what we do, and of course, paving the way to a future we thought was impossible. The management and PR team certainly played an important role in this team. However, I would like now to present you another vital team that was key to our achievements. I would like to present to you Sheila Marie Gabe, Head of Operations.
Good evening, everyone. I am pleased to present. Well, good evening again. I am pleased to present to you a sub-team that works behind the scene to help bring the ideas of our engineers to life. Operations was recently founded, but we quickly became an integral part of the team to ensure a smooth and efficient season. Our main responsibility lies in procurement and production. The procurement process is critical for any team to function efficiently, and the operation is at the forefront of this process. We are responsible for sourcing and acquiring the necessary goods and services, and this includes collaborating with sponsors and suppliers, managing budget, and making sure that all materials are acquired in a timely manner in accordance to the timeline of every sub-team. We are also very fortunate to have the support of many sponsors from all around the globe, as can be seen from the map. The fact that our sponsors come from different countries truly speaks to the international nature of our team and our project. It also highlights the fact that we are not limited by borders or geography, but we are united in our shared goal to create something that's really exceptional. We are able to connect with like-minded individuals and organizations who share a passion for innovation, efficiency, and sustainability. And without them, our goal would be unreachable. And once every part and material are procured, we can now build the car. The production management is critical to the success of any manufacturing operation. One key aspect is organizing shifts to ensure that production runs smoothly around the clock, to maximize production output while also minimizing downtime. In addition to organizing shifts, developing standard operating procedures, or SOPs, is essential to ensure that everyone involved in the production follows consistent guidelines. These guidelines outlines the steps that must be followed in every stage of the production. Trainings are also provided within our workshop and in collaboration with our industry partners. This allows everything to be conducted efficiently and safely, thus minimizing the risks of accidents and defects. By following strict quality control procedures, we can ensure the car in the end will be able to perform at its best. Lastly, at TUfast ECO team, we are committed to not only promoting efficiency, but also to advancing sustainability and environmentally responsible practices. Rather than contributing to the problem, we are dedicated in being part of the solution. Therefore, as part of our efforts to reduce our carbon footprint, we have decided to use solar panels to recharge our batteries. This allows us to reduce our reliance on non-renewable energy sources and move towards a more sustainable future. The solar panels are also portable and offer endless possibilities and can be used by future seasons. We also started researching for a renewable material that is sustainable, and our answer was using flax pre-pack. Flax is an ideal rotational crop and is often cultivated for its fiber. It requires minimal amount of energy produced, and the production does not generate large amounts of greenhouse gas emissions. Flax also has the potential to be recycled or biodegraded at the end of its lifespan. As a team, we are passionate about sustainability and recognize the urgent need for a shift towards more environmentally responsible practices in the realm of future mobility. With climate change and energy crisis posing a threat, we are focused in finding efficient solutions to these pressing issues. Our aim is not just to follow the road towards green mobility, but to lead it. I would now like to welcome to the stage one of our engineers who will show you how we design a car that paves the way towards a sustainable future. Marius Wendler, our head of vehicle body.
Ladies and gentlemen, I hope you're having a great evening. Reducing the driving resistance forces of a vehicle helps reducing its energy consumption massively. Especially for our carbon footprint, this is crucial, but also for the range of driving with one charge of battery. When it comes to efficient driving, I often get asked the following. Why do we focus so much on the aerodynamics of the car? You're driving only with the average city speed. And it is true. In the equation of driving resistance forces, next to the weight influence, the drag force is proportional to the velocity squared, influencing it very much at driving with highway speeds. But our car does not weigh 1 or 2 tons. It weighs below 70 kilograms, lighter than its driver. In this ratio of resistance, this means that a third results from aerodynamic drag. Now, our goal this season was reducing the drag coefficient of our car to the optimum. Our prototype bases on the car of the season before, muc023. It has the similar main structure and the similar passenger cell. We were given quite a good position regarding the aerodynamics of the car, with it being shaped similar to a rain droplet. Now, to make things even better and optimize the aerodynamics of the car, we did not only cover the rear wheels, but also the front wheels. And even though we had to increase the front width of the car a little to ensure maneuverability, this reshaping the front of the car already gave us a drag force reduction of 7%. And we went on in the front. We created a smoother transition between the bonnet and the windscreen and shaped a sharper nose of the car, but also in the back with a steeper rear floor line. The drag was reduced more and more, step by step, as it goes through aerodynamic simulations. Now, to amplify our drag force reduction to the maximum, we were able to use an innovative technology called a joint optimization. In this process, a simulation showed us the direction of the most aerodynamic shape. This resulted in forming a channel in the tailgate in the back of the car that leads the airflow directly into the wake zone. In total, we were able to reduce our drag coefficient to just 0.13, a great improvement from the 0.16 from the season before. As a comparison, normal street cars have CD values ranging from 0.2 to 0.3. Coming back to the driving resistance forces, of course, weight plays a massive role. Now, our goal in vehicle body was to reduce the weight of the passenger cell, a monocoque, even more. And the monocoque is still the best construction method for prototype cars like ours, to have this main structure carry all the forces while driving, especially for prototype cars. Since carbon fiber is one of the best materials when it comes to the weight to stiffness ratio, almost the entire vehicle body was made out of it, as in the seasons before. Now, to quickly understand what we changed this season and how the material works. Multiple layers of carbon fiber are stacked above each other, connected with the resin matrix. In between, a lightweight material, such as an aluminum structure shaped like a honeycomb, is added to increase stiffness, creating a sandwich structure. Now, to improve our monocoque to the maximum, we reshaped it in the front, used FEA simulation and a so-called free size optimization. This way, we were able to see exactly where and how much carbon fiber to use, according to the tensions. Not only did we perform apply and a thickness optimization that way, we also varied the thickness of the aluminum honeycomb core. Ideally, increasing it gives us more stability and more safety. To save weight, we decreased the thickness in less stressed zones, but increased it in highly stressed zones. This way, we made it not only lightweight, but also safe. Still with the same safety and the same load cases, we were able to reduce the weight of the passenger cell from the predecessor by striking 4 kilograms to now just 14.7 kilograms for the whole passenger cell. And we continued to minimize the weight for the whole vehicle body. Through inspecting various materials and carbon fiber types, simulation, and the experience gained from the years before, we were able to reduce the weight for the whole chassis by 21.3% to only 25.2 kilograms, carrying all loads, protecting the drivetrain and the electronics, and forming the aerodynamic shape that defines our car. Now, our car is a prototype, an urban concept. It does not have massage seats, big screens, or a sound system. Cars in the future probably will not have such a lightweight chassis or such a low drag coefficient. They might not look like this, at least not exactly. What we want to do is to shape the mobility and the cars of tomorrow in a more energy-saving and sustainable way. And it shows in which direction we have to go, in the direction of efficiency. And of course, our chassis needs a strong and efficient structure that makes it drive and thrive in this direction. This has been done by the running gear team, led by my colleague and head of running gear, Pedro Redondo.
Ladies and gentlemen, good evening. As you could see, I'm here to talk about a very critical component of every car, its running gear. It consists of various parts that work together to transmit the engine's power to the road. Starting at the drivetrain, going through the wheels, passing by the brakes, being guided by the steering system, and held together by the suspension. It's responsible for the car's stability, handling, and overall performance. With a system so complex, you can imagine the potential for efficiency behind every moving part. One of the most critical factors when designing such a car is, of course, lightweight design. And that's precisely why we made it our top priority. By redesigning the entire suspension and brake systems from the ground up, we were able to reduce the weight of our mounts of their already optimized machine counterparts. Additionally, with much lighter rims, we not only saved drastically a lot of weight, but we also reduced the rotating mass, thus putting even more power into the road. By doing so, we were able to unlock its full potential and transmit and create a car that is both agile and powerful. By redesigning, we could only achieve this with these methods. We achieved a staggering 7-kilogram weight difference, reaching a mere 17-kilogram weight reduction. Running gear system. We could only achieve these results through the power of extensive simulation of every component. We first optimized the drivetrain by designing the suspension dampers accordingly and providing for a smooth ride with minimal losses. This allowed us to calculate the acting forces on the car and define the suspension kinematics. Using multi-body simulation, we were able to analyze how the forces distributed themselves in the complex arrangement of carbon rods and metal mounts. We then restricted the parameters and used this process called topology optimization to design all of our parts. This iterative design process incorporates finite element analysis to provide with recursive feedback and removing material little by little until we've reached our final design. Using all these methods, we designed our metal parts and, most importantly, our uprights. These parts sit at the very center of the wheelbase assembly, and they are responsible for transferring the entire weight of the car into the wheels. Our goal was to achieve a geometry that perfectly shows the flow of distribution of forces, thus producing a part that is both lightweight and incredibly durable. And we are proud to have achieved such significant weight reductions. To produce these cars, we used a process called selective laser sintering, or 3D sintering for short. In this process, powdered metal is heated and fused together layer by layer, producing a three-dimensional object. This method allowed for the creation of complex geometries that could not be milled in traditional production techniques. With the use of these advanced techniques, we were able to produce lightweight and robust system, helping us achieve our goal. But we didn't stop there. We also optimized the drivetrain, further improving the car's efficiency. To achieve the right balance between acceleration and energy consumption, we simulated the drive of the competition track to define the suspension, the optimal motor size and quantity in the car. By simulating real-world conditions using computational fluid dynamics, we were able to choose the right lubricant, helping us reduce the wear and tear in the engine, thus ensuring longevity and reliability. And after conducting multiple optimization techniques, our planetary gear system went through multiple minute changes in its tooth geometry, reaching an optimal shape and gear ratio. With all these efforts, we were able to create a system that maximizes its performance while minimizing energy losses. In conclusion, by prioritizing the efficiency and pushing the limits of mechanical engineering, we are proud to be leading the way of the future of mobility. But of course, to make this all possible, we need a team of extremely competent electrical engineers to take every last drop of energy from the motor to power the car. And to talk about that, I'm very proud to present to the stage my friend and colleague, Jonas Uffinger.
good evening, and a warm welcome to all of you also from my side. Along with my colleague, Pei Lin, I'm honored to lead the electrical engineering team, which is dedicated to finding the most efficient solution to convert the chemical energy stored in the battery to the kinetic energy of the motors. In order to achieve maximum efficiency, it is essential to minimize the losses that occur in energy conversion of the electric powertrain and to find the most efficient solution for the peripheral electronics. Therefore, our team is constantly working towards finding innovative ways to improve our electric design. As widely known, the most efficient form of storage for electric energy are lithium-ion batteries. With a remarkable efficiency rate of 98%, we can extract almost all energy back when discharging. This is the reason why we have chosen this technology for our car, as opposed to other technologies, like for example hydrogen, that only reaches 60% efficiency. However, we understand that the production of lithium-ion battery cells requires lots of valuable resources. We've developed a battery management system that constantly monitors the battery's state of charge and intervenes before unfavorable charge conditions can damage the battery. Due to the chip crisis in the last couple of years, we were forced to integrate a different cell monitoring IC than intended in the design phase. However, here we proved once again that we are always able to adapt to new challenges. Then, to convert the electric energy taken from the battery into kinetic energy, we need motors. Here we decided to use permanent magnet synchronous machines due to their lightweight, high power density, and efficiency. Also deciding on a more powerful motor with increased torque, we were able to switch to a single-wheel drive system, and due to our lightweight vehicle design and our efficient powertrain, we were able to reach our desired track speed with less than 1 horsepower. To control this motor, we've developed a new inverter in the last 3 years. Efficient switching is of utmost importance here, since this is where the energy losses occur. Unlike the widely used MOSFET or IGBT technologies, we use GaNFETs that switch more efficiently in our power class. This is how we reach an overall efficiency of 94% at the optimal operating point. Next to this energy converted in electric powertrain, it is necessary to minimize the energy consumed by our peripheral energy consumers. Efficient power regulation between the different voltage levels, minimum power communication between the boards, and low energy appliances are key factors here. With the help of power distribution network simulations, we were able to create an extremely compact power regulation, distribution, and logic unit, the so-called main control unit, or as we like to call it, the Wonderboard. It combines the tasks that were previously performed by 4 different PCBs into one single board. Therefore, and also due to several new design changes, we were able to reduce the overall weight of the electric system by more than half a kilogram, also contributing to the lightweight vehicle design. In conclusion, efficiency is key when it comes to power conversion. We believe that with our chosen components and strategies, we are able to shape the car of tomorrow. But since muc023 is also an autonomous vehicle, I'm now honored to introduce my colleague Eddie Groh, presenting the journey of how our car paves its own ways into future mobility.
Welcome. I would also like to wish you a pleasant evening. I'm honored to lead the autonomous team together with my colleague Flora Todt towards the goal of enabling muc023 for autonomous operations. This task requires diverse skill sets ranging from software programming to electrical and mechanical engineering. Our ultimate goal is to make driving efficient and effortless for everyone. Therefore, I'm proud to present our finished product, the autonomous system of muc023. Our system boasts 360 degrees of vision achieved with 1 LiDAR and 5 cameras mounted on the roof of the vehicle, allowing us to monitor its surroundings regardless of the car's or the target's movements. The combination of a LiDAR and a camera on each side at the front of the vehicle allows for comprehensive and precise scanning of the environment in the forward direction. Notably, the depth camera alone, mounted in the middle, is able of generating over 1 million colored points per second, creating a wealth of high-quality perception data for detecting signs, road markings, and much more. With the inclusion of a long-range LiDAR sensor positioned alongside the depth camera, we enhance the vehicle's perception capabilities by detecting obstacles up to 300 meters away. With this extended perception range, we allow the autonomous system to proactively react to potential obstacles and avoid them by making timely decisions and ensure a safe navigation. Our global navigation satellite system, equipped with an integrated inertial measurement unit located at the back of the car, allows us to position the car worldwide with sub-centimeter precision. All 7 cameras transmit data directly to a specialized video grabber card, which writes the data into the computer's main memory for further processing. Our computer, half the weight, double the performance as the previous season, creates a plan, which is then translated into motor signals by a real-time machine located next to it. This real-time machine is responsible for tracking the car's position, and it will apply small corrections to ensure we accurately follow the planned trajectory. For steering the car autonomously, we have designed a system where a steering motor, which is directly attached to the steering column, is paired with a powerful motor controller. This setup allows for precise and smooth steering, even at high forces, while still allowing for the flexibility of driver-controlled driving if the steering motor is disengaged. In addition to all this sophisticated software, we also have sophisticated software. In addition to all the hardware, we have sophisticated software algorithms to process data, make decisions, and control the motors and other subsystems. Specifically, all camera data is either pre-processed by custom-made neural networks or directly combined with depth information. In order to recognize drivable roads and other objects, our neural networks have been fine-tuned on thousands of hand-picked pictures. With the addition of depth information, we allow the system to accurately determine the 3D shape of the detected objects, which is crucial for spatial awareness. All this data is then combined in a 3D voxel-based map, which is almost perfect representation of the real world thanks to our accurate positioning. We limit the map's detail to allow the storage of all the detected information in a memory-efficient way, while still allowing us to access and process the data with low computational effort. By storing all this valuable data, we empower the vehicle to not only perceive the world in the current moment, but combine all the collected data to form a more accurate and complete view on the world. This map is then used by our navigational system to find a goal, plan an optimal trajectory to it, which is then executed by a real-time control system. Our work aims to pave the way for a more efficient and safer transportation, benefiting all types of vehicles. By leveraging autonomous driving technology, we hope to reduce costs and increase usage periods for all types of transportation, ranging from small delivery robots to articulated buses. This vision includes optimizing routes, minimizing energy consumption, and improving traffic flow for a more economical, environmentally friendly, and accessible transportation system. Therefore, I am confident the future will drive itself.
After hearing all about our subteams and what they achieved to bring this vehicle together, we are now very happy to proceed to the final moment of today's presentation. We will show you what made us stride forward relentlessly the last couple of months and what we are tremendously proud to present to you. We went above and beyond to create an autonomous vehicle comprising aerodynamic optimization, lightweight design, and minimal losses across all systems. Our goal with this car is to show what individual mobility should be about. We want it to be an inspiration, a vision for everything that will follow.
And with that, we are thrilled to reveal muc023, our 5th generation urban concept car that embodies everything we stand for. This is how efficiency paves the way to our future. This is muc023.
Thank you everyone for being with us tonight. Now we would like to take a team picture, so I will call them to each sub-team separately. So, please welcome to the stage the management and PR team. Next, please welcome operations. Hello. Now, welcome Vehicle Buddy. Now, Running Gear. Now, the Autonomous team. And lastly, Electrical team. Move to the front. You're small.
Let's drive away till the sun comes up, and let's get lost under the stars. Let's follow our wildest dreams tonight. No one can ever make you feel the way that I do. And I feel different when you're here. I lose myself in you. We go up, like flying up to the moon. And we go up, and think about how to let it go. We go up, like flying up to the moon.
Ja, genau.
Think about how to let it go. I wanna be right next to you and never let you down. I wanna be right next to you and never let you down. I feel like everything makes sense sometimes. Everything feels on repeat. I feel invincible.
Enjoy the evening and please enjoy the food in the buffet. Our team members will go and open it so you can already start gathering there. Thank you very much.
And we go out, don't think about how to let it go. I wanna be right next to you and never let you down. I wanna be Can't keep on losing you over complications. Gone too soon. Wait, we was just hanging. I can't seem to hold on to. Dang, the people that know me best, the key that I won't forget. Too soon. I can't keep on losing you. I can't keep on losing you. Yeah. How many mistakes do it take till you leave? And I'm left with my hand and my face all red and the face looking at you like, wait, I know I ain't a saint if it ain't too late. Well, I can't keep on losing. I run away so fast, but my heart like gold, but it break like glass. No, my shit